Okay, let's start off nice and easy. Who got the first one? Okay, what is it? All lines are straight. It's a line. Okay. What's the slope? 1, right? Because 1 times x. Where does it cross the old y-axis there? -3. Melissa, what did you ask? About points or something?
I was asking if you wanted points to figure out what.
Yeah, we're going to try to focus on not specific points, except for ones like where it crosses an axis, or points that don't exist. Okay, those are the points that we're going to care about. We're not going to graph like 1, -2, 0, -3, -1, -4. Okay? Yeah. We're going to stay away from that because unless we're talking about an actual line, it's going to be rough relying on those. Okay. This one is slope of 1 goes through -3. Okay. You should need maybe 1 more point, right? So you can use that slope of 1 for something. So maybe I come down here to -7, -10. So I have a second point. And then I can line it. Yeah, hopefully that's a line. Okay.
Hopefully that's a line.
There we go. Ta-da! Okay, now, what about that x -3 quantity squared? What is that? It's,
weird.
I think it's just, what do you mean by weird looking?
Well, I mean, it goes like this, but at least when graphing out, it looks like there's 2 bottom.
Yeah, that would be weird. That's not what's going on. Yeah. Where's the vertex of this parabola?
-3.
Yeah. Okay, so one thing to recall, and maybe you want to put this in your notes. Maybe.
Do we? Are we? Okay, this stuff that we're learning right now, we're going over now.
Yeah.
Are we? This is for the problem set.
Yeah. You can put this in your notes just as well as doing it on board. This is the standard form for all parabolas. I mean, we could multiply this thing out. Actually, standard form would also have like an A here, but we're not going to deal with numbers in front of the parabola at the moment, at least. That would just make it skinnier, taller, or something. Okay? Why is this the standard form for parabolas? Why does this help us draw a parabola quickly and easily? What do you mean by axis? Oh, what do you mean by that? What do you mean we know what y and x?
Well, if you were plugging in the numbers that you're trying to find.
Yes, but we could just as easily have done, y equals x squared minus 2xh minus 8 plus k.
Apparently this is easier. So.
Yeah, apparently this is easier. How so?
I don't know.
Becky, what do you think?
It's like HK or something.
What about hk?
That's like the vertex.
Yeah. Becky got it.
Oh.
No, just H. Like 0. So it's like.
Right, that's what makes this a nice form. Okay? This is why in Algebra 2, at one point, we started off with like y equals x squared plus 3x plus 7 or something, and we made you complete the square so that we had something that looked like a square plus something else. Okay? Even if you don't remember the whole process, that's why we had you complete the square. Because when it's in this form, when it's x plus or minus something, quantity squared, plus a constant, that shows you how it's been shifted, basically. Right? It's been shifted, how far, and how far to the right or the left? How far has it been shifted horizontally?
-3.
This one.
Just 3.
This one.
Negative h.
Nope.
Just negative.
Positive h. Right? It's been shifted
Minus in my here.
h to the right. And how far up or down has it been shifted? K, up. Okay?
Wait, so.
That's why the vertex isn't at 0, 0.
So it's not negative 3, 0.
Oh, it's a 3.
It's at h, k.
Wait,
So
but K
even
is
if
0.
Perfect.
so even if like it's x minus something,
Mhm.
it's still gonna be positive. It's not gonna be negative 3.
Correct. It's x minus h. So back here, how far has this particular parabola been shifted to the right or left?
3.
It's been shifted 3 to the right.
Yeah, but then the vertex would just be 0. Wouldn't it? So it's just
I don't know what you mean by
Or the K would be 0.
yes. So what does that mean?
Then it's just on the line.
Yeah, it's not shifted up or down at all, right? Not shifted up or down. It's just shifted 3 to the right. Yes, we learned this in kindergarten when we were talking about transformations. Okay, when you change the x part, it's a horizontal shift, left and right. And you can think about it, if you want, as you sort of do the opposite of what you see here. This is x minus 3. That means that it's been shifted 3 to the right. This one has plus 0. It's not shifted up or down at all. So that means we know where the vertex is, which is right there. Which makes sense, I hope. What happens when we plug in 3 into this equation? We get 0. Okay? So that should help us remember that we're not looking at this point over here. Because, yeah, if we stick in negative 3, we're talking about 36. It's negative 3 minus 3. Which is negative 6. Squared, that's 36. That's a big number. Okay, what do we do from here once we have the vertex? How do we draw in the rest of the points of a parabola, like a couple more points?
You can
Go ahead, Scott.
make a parabola shape. Or you can
Well, I want a little bit better than that.
you can do x and y.
I don't know what that means.
You can do if x is 1 and then y is
Just plug in the next.
Oh, you mean find points by plugging in x values? Okay. We can do that, but there's something that is better. Julio.
I was gonna say take the points on either side of the axis.
Yeah. So first of all, we know it's symmetric across the center, right? Where the vertex is, it's symmetric on either side of that. So if we figure out one point on one side of the parabola,
And it's gonna be
we know it's going to be the same height on the other side of the parabola.
2, 1, 0.
Yeah, the other thing is, there's nothing in front of this term here, and so there's a pattern that we can remember. Okay? First, you go up 1, and then of course you do that on the other side. The next thing is if we go over another 1, we go up 3 from where we just were. 1, 1, 2, 3. And same on the other side. If we go over 1 more, how much do we go up?
3.
Nope.
6.
First we went up 1, then we went up 3,
Then you go
and we're going to go up 5.
do y.
Which makes sense, right? Because we're 3 away, that's like 9. Right, 3 squared. And so 1 plus 3 plus 5 is 9. You can think about it that way, or you can plug in a couple points on either side. When you're doing a parabola, give me at least 2 points on either side of the vertex and the vertex. Okay. You don't need to like draw in a huge number of points, just 2 on either side of the vertex. Okay, so this is the parabola. And if you were one of the people that, drew the parabola like this, you see what's wrong with that, right? I mean, it's not that. We need to be a little more accurate than that. Okay. What about that last one? We talked about this at the very end of class 2 days ago.
This is cute.
Oh,
Actually, not that bad.
It never gets above 1 when it's negative.
But,
It never goes above 0.
well, I mean, it also never goes above 1. But yes.
Never above 0.
Oh,
Okay, we need to remember, this is, I'm not writing stuff down for a line, because I'm assuming you remember that. But for the inverse function, which is y equals 1 over x, that's a kind of hyperbola. Let's just think about quadrant 1 for a second. As x gets huge,
It gets infinitely small.
y gets really, really small, or really close to 0. Okay. Does it ever reach 0? No. Because you can't divide something and get 0.
so that's the inverse of the y.
Okay.
It's the y equals 1 over x. That's the inverse of the last equation, or is that?
Okay, what happens as x gets really, really tiny? Y gets huge. Okay, if you divide by 0.01, it's the same as multiplying by 100.
Wow.
If you divide by 0.001, it's the same as multiplying by 1,000. Okay, so we're looking at this. Okay, this graph appears all over the place in nature. Look, it's also a supply versus demand graph.
Wow.
Look, it's also predator-prey when there's an excess of predator. I mean, there's lots of different ways this happens. All right, what does this look like in the fourth quadrant?
Reverse.
Reverse like this.
Flip.
I thought it was in the third.
Oh, what? But I'm asking about the fourth.
I was just guessing.
Okay.
Negative.
2 things. First of all, if we're in the fourth quadrant, x is positive, right? And y is negative in the fourth quadrant. So when do you take 1 over a positive number and get a negative number?
No.
When you get 1 over a positive number and get a negative number. You just don't. Okay? So that's one way to think about why there's nothing in the fourth quadrant. The other thing is, this is a function. If I had anything in the fourth quadrant, what would happen?
It would be like the vertical line test.
It wouldn't pass the vertical line test, right? Doesn't matter what this thing would look like. I'd always be able to draw a vertical line. Okay? So, inverse has nothing to do with nothing in the fourth quadrant. Now, Ryan, in the third quadrant, what's going on?
It's like flipped. Like
Yeah, it's flipped across the origin, flipped through the origin.
It's just mirrored, isn't it?
Yeah, you can think about it like that. There's actually lots of different orientations you can think about it being flipped over. Yeah, and again, there can't be anything in the second quadrant,
Zero
because
is-
then vertical line test, we wouldn't. Or, we can't have a negative x and a positive y.
Doesn't make sense.
Doesn't make sense for this equation. Okay, this is what 1 over x looks like. So, what would 1 over x minus h plus k look like?
Well, it would be
It'd be like shifted.
Shifted which direction and how much?
So it'd be toward the right H and.
To the right h, because that's how the x is shifted,
up
and
K,
up k.
which we don't know what H or K is, so.
Well, but I mean, I could define it like, here's h, here's k. You might think about drawing in like a set of axes that go through h comma k, right? This is the center of this thing, just like the origin is the center of y equals 1 over x. You may want to. Wow, that was awesome.
You should have just done the line thing.
I should have.
So
Okay, you might want to draw in your axes because those are your asymptotes, and then draw in the graph. Just get close. I'm not even asking you to solve for specific points for this one. Make sure that you draw in asymptotes and then draw it relatively inversely.
So do they always have that shape when it's 1 over something?
Yes.
What makes it?
Yeah. Because as we approach h, as x approaches h, what's happening?
It's getting bigger.
Because
Because it's a fraction. So it's reverse.
yeah, we're dividing by something smaller and smaller, which makes it huge. Live.
Oh man. Oh, it's like 2 over X or 3 over X.
Right. That just like anything else, we're just multiplying the whole thing by something, and so that makes it taller or fatter. But it's hard to define what taller means for this thing. It's like, oh, well, it could be this, or it could be this, or it could be this. I mean, it's get the approximate shape right. That's what we're trying to do, is get it to look like an inverse.
It's just not gonna go back up.
Yeah. Okay, so
What?
on your board, if you haven't already, sketch 1 over x minus 3.
Minus 3. So wait, would this one be? No.
Is this close to right? I don't know.
It's close to half, right?
They can be here too.
Alright.
Yeah.
Oh.
I think I got this wrong.
You're about half right.
Wait, so you would do this, so that's gonna be here. You would have to make it here.
How much is it shifted up and down?
3. Why would it be negative 3? Oh wait, this is not like the other one, so it is
Yeah,
negative.
there's no plus here. There's no 1 over x minus 3.
I thought whenever you said
All
when
plus
there's a
7.
negative 3, it's h is just gonna go over itself. Okay. So it's gonna be more like this.
About half right.
It's over 3.
Yeah.
Yeah.
Make sure you are drawing this in and not just drawing dots. Okay? These graphs are not dots. You graphs are curves,
I like
curvy lines.
I like to think on those thoughts. Thank you very much.
Okay, so the asymptotes are, it's not shifted up or down at all. Okay, so one asymptote is definitely just still the x-axis. The other one shifted over to the right 3. Oh look, it's the same axis as the parabola.
You
How
said it's negative 3.
convenient.
You said it's negative 3.
No, it's always opposite.
That's what I did. You said I was wrong.
You said you were talking about shifting it up.
No, I was saying over 3, and then you said
You said
no.
up. You might have meant over.
I said, can I do this? And you said, no, you have to move it to negative 3. And I said, oh, like this? And you said, yes. It's wrong.
Okay, I must have misunderstood what you were saying.
Okay.
Okay, something like that.
Oh, you have both.
Right? You gotta have both.
What's this?
Okay.
Second.
Oh, half one over.
It's not going to have a different
Yeah.
Yeah.
These are yours.
It's shifted 3 to the right. Right? It's not centered on the y-axis. It's shifted over 3 to the right.
Yeah. Like
Yes.
So the shift the top third of the.
The top's the same.
I think he started it here. You had it straight there.
Well, it's just because you drew it straight. It's not really a straight. It certainly doesn't touch actually in real life, right? You can't touch an asymptote. You can while you're approaching infinity. Yeah. Okay. Okay, now let's practice some more.
What's that?
On the same graph.
Yeah, I would start over if I were you. Probably 3 graphs on the same thing is the limit of what you can do will still be easily understandable. Okay, think about what kind of overall shape that is. And then think about how it's moved around from just being centered at the origin like it normally is.
Why is H now equal? So we switched H with F?
Oh, this was a G, that's what it was.
A G, okay. I was getting confused.
Well, it doesn't matter, right? I mean,
It doesn't really matter.
they're all just functions. I was wondering why I had a 9 up there, because this graph was covering the tail of the G. So yeah, these are all just some sort of line, some sort of graph. And you know, I was a little glib earlier when Khalil said a straight line. Right, because Scott education, this is the kind of stuff that's still important. Any curve can actually be called a line. And mathematicians call this a line. They also call it a curve. Okay? But you can ask, what kind of line is this? So what kind of line is it? It's a parabola.
Did it.
Okay. Oh, listen.
So is it -2, 5, or 2,
What do you think?
Is this right?
I thought 2,
Why?
-5 because it was minus before and then equation thing.
Yeah, no, it's the first thing you asked was right.
Okay, so it's -2, 5.
-2, 5.
So you said
You can think about it that way, yes.
Oh, wait. Oh.
What's really going on here is, how would we make this squared thing 0? what would x have to be to make this squared thing 0? -2. Okay, so that the origin has to, or the vertex has to be somewhere where x is -2. But then we're subtracting 5 from the whole thing. That shifts it down 5. So -2, -5. Down 5. -2, -5.
Wait, so then I was right. I'm confused. So it's not up. So if it's -5.
Maybe it would help if you labeled your axes. Because maybe you're
This is
drawing
X,
it
this
in
is
some sort of
Y.
correct way.
-2 is 1, 2.
It's -2 for positive 5.
No,
right?
-2, -5.
Wait, so I'm gonna switch the first one.
Sure.
Always?
Well, the x, yes.
Yeah, okay. Okay, so you keep the -5, that's.
Yeah.
What did you get, Clem? I didn't get that. Would you be going down though if it's a negative?
What's a negative?
-5. Oh no, I see what you're saying. I think. I'm wrong. I'm sorry.
Okay, let's see what we got.
Forgot, graphing's not my friend.
But it can be.
I want to see what he gets, and then I'll say if I got it. Yeah, that's what I got.
Okay, we had h was x plus 2 quantity squared minus 5. If you have trouble remembering which one you sort of like do the opposite of, you can actually think about it like this if you want to, because this is really what's going on. Right, if we do the y shift thing over here with the y, where it sort of belongs, just like the x shift part is with the x,
Oh.
now it's, you do the opposite of both. Oh, that's a plus 5.
Yes.
You go down 2 and down 5. They're both plus, so you do them both minus. The confusing part is when we say h equals something, now it's like you do the opposite for the x but not for the y. You get to pick which way works best for you. That's the exciting part. But the vertex should be there.
I got that part.
-2, -5.
That's -3.
Oh, is it?
A little bit.
It is.
-3, what you talking about? Oh, that's -3. Yeah.
Now, how do we find some other points? I need 2 points on either side.
Just do 1 and 1.
Yeah, you know that the first one is going to be 1 up and 1 up.
And then you go the next one over, you go up 3.
Next one over, you go up 3. Oh, 1, 2, 3.
And then
Or you
next
can think
time-
about it as a total of 4, right? You went up 1, then you went up
And
3.
then you do the same thing, but do it 5 instead of 2.
And then connect the dots. In some sort of semi-pleasing way. Goodly enough.
Wait, so you go out and you go up 4. See?
if you move 2 away from the vertex,
I can use that.
Yeah, I knew where to put the initial point, but I'm confused on how to like quickly figure out where.
okay, well you got 2 choices.
I know you go up one.
3, 5.
Yeah, every time you go out 1 more, you go up the next odd number. So first is 1 and 1,
Always
you move out 1 more, and then 3, 1 more, and then 5. Yes, because the sum of odd numbers is always a square. 1 plus 3 plus 5 is 9, 1 plus 3 plus 5 plus 7 is 16.
It's the same no matter what H and K are.
Yeah.
Everyone is
The other way to think about it, instead of doing just steps, is if you're 1 away, well, what's 1 squared? If you move 2 away from the vertex, well, what's 2 squared? 4, so you should be 4 up. 2 over, 4 up. 3 over, 9 up.
Wait, what if it's like x plus 9?
What number would have to go into the function to change the
Touching on the outside.
Yeah, that would be a multiplier out here.
Okay.
Because then, if this were like 7, we'd move 1 away, but instead of 1 up, we'd go 7 up. We move 2 away, and instead of 4 total up, we'd go 28 total up.
Wait, would we
Seven.
like, if it was enough to get the number in front of the X or in front
That's
of
like
the whole?
The whole thing.
It's like 7, X plus 2.
Yes. If the 7 were inside, our first step would be to pull it outside, which would get ugly. If it were like 7x plus 2 squared like this, the first thing we'd have to do is factor out that 7. And of course, it's inside a square. It'd be like 7 squared. And then it would be x plus 2/7, because we factored out a 7. Yuck. But that's what we'd have to do because the vertex is going to be at negative 2/7. It's not going to be at negative 2. Yep. But we're not going to deal with those. Not for now. Okay, no coefficients in front of the x part for now. I'm going to get the basics of graphing done before we do that.
No. 2002.
Are you learning this like actually in the future? When everyone's here?
What? Aren't you learning it now, Michael?
Yeah.
Okay.
But I mean, are we going to continue with this?
Yes.
Why not?
We talked about that for like 20 minutes on the first day of third trimester.
Did we?
That's a long time.
Yes, right. We're mixing in some other topics as they come along. Because we didn't cover as much as I want to. Plus, there are some things that this is going to help us when we start graphing the trig functions.
Graph.
Yeah. Good stuff. Okay. Next.
Very kind. Yes.
Try this one.
I don't know if I'm supposed to flip that. No.
Your first step might be to rewrite it to put it in a form you're more familiar with.
Wouldn't it just be the same form now?
Pretty much.
Yeah. That's what I think. So it's going to be 3 or 1, 3, and it's going to be. How do you know if it goes up or down? That's where I'm getting confused on. Both of them are negative. Is it when the x is negative? Because
Okay,
you know
the
how.
H and the K
Yes.
have nothing to do with whether it's going up or down. Nothing. They locate the vertex.
Okay.
That's it.
What determines if it goes up or down?
Think about what we were talking about. If I had been multiplied by 7, what you do.
Oh, yeah.
Okay. Think about what might flippity do upside down. So when I say rewrite it, the first step, 4 minus x minus 3. Oh, I used K. I thought it wasn't the best idea.
Yeah, I was just thinking that too. I was like,
Sorry.
okay. I just ignored it and said,
Yeah.
pretend it's a Y.
Okay, this was the function, right?
2. Wait, no, yeah.
Can you do like x minus 3 squared equals 4 minus x? I mean 4 minus k.
No, this is our y. We want to keep that there. However, I would totally make it look more like what we're familiar with. Thank you. Right, switch it so that the squared part is first. Thank you, Mr. Klingler.
How would I be wrong?
Negative 3 means you shift it to the right.
I did shift it to the right.
And the positive 4 on that side means you go up.
Did I do? What was the original? Oh, I had it upside down. I did it. I did it upside down.
Yeah, that's why you gotta label.
That makes, yeah, I'm sorry.
Okay, does everybody see the negative x minus 3 plus 4? Okay. So first of all, where's the vertex? 3, 4.
Positive 3.
1, 2, 3. 1, 2, 3, 4.
I have a question.
There's the vertex. Yeah.
Okay, so when I did like the mixing of everything, and I did like, and I got like 4 minus k. Okay, like I added x minus 3 squared to the other side, and then I got it looked like that, and I still got 3 components. You understand what I'm saying?
I don't.
Okay, wait. Okay, no,
Fine.
it's like, see, I don't want to be like negative, so I added that.
Did you go up or down?
Yeah, no, you're gonna have to do it with negative.
Okay.
There's no escape. You're gonna have to do it with negative. If we were solving to get like a number, then totally I would get rid of the negative by like adding to both sides. But here, we're trying to figure out a function that's going to be negative no matter what we try to do. So we've located the vertex. Now let's get some points. Ryan, I think I heard you say that you knew what was going on. What's going on here?
Oh yeah, that's why I had it first. This is a different question, but wouldn't the negative distribute over and turn the negative 3 into a positive 3? Or no?
Nah.
It wouldn't?
Nah.
Okay.
First of all, I'm not sure what I would do to get the negative inside the square. We'd have to put it as square root of
Okay.
negative 1
Square first.
times
right.
x.
Okay.
Yeah. So we'd have to have I in here. X.
So then,
Let's not do that.
I just,
Polio, what do you got?
I put 2, and then I got 2, and I realized it was going down.
Yeah, move 1 to the side. It's always move 1 to the side.
After that, I didn't have to do math. It's just
Yeah.
gradually.
I don't care which x value you put in there, 4 or 2, but move 1 away from 3. See what happens. In this case, if we move over 1, we go down 1. And on both sides. What if we move over 2? We go down a total of 4.
Oh, but it's negative.
Yeah. Remember when we were talking about if I'd had a 7 out here, we'd multiply everything by 7? Same thing with a negative. For those of you that asked, hey, how do you make it go upside down? You must have known I was going to do this problem next.
I might have, if I wasn't dumb.
So when we go over 2, we go down a total of 4. If we move over 3, we go down a total of 9. Or 5 more. your choice about how you want to think about that. Wow, look, those guys sort of.
They're like best friends.
Yeah.
It's like Spider-Man and Mary Jane about the kiss.
Okay, let's take a look at this last one. We're going to take a small break. What do we got?
What do we got?
What's we got?
We got a problem. That's what we got. You know. Do you not know the song? Even believe it's not so. It's magic. What do we do with the two?
Wait, it can't be in the fourth quadrant. Or can it?
Not in the fourth.
Or is it,
You
can't be
redefine the
100%
axis with
one?
the vertex.
Do we have to?
Fourth quadrant movements. It's not in the fourth quadrant.
Well, let's say that again louder.
You're kind of, it's almost like you redefine the axis when you, with the vertex. The fourth quadrant of the board is not the fourth quadrant of this equation necessarily, because it's.
Yeah, you're drawing in new asymptotes, right? Say yes.
Yeah.
When you draw in your new asymptotes, it's that fourth quadrant that you can't draw. It's going to be the first and third quadrants. From your- Yes.
Wait.
That's again why it's important to draw in your new asymptotes.
Okay, so then like,
So the axis
so
would
be
be
3, -5.
there's the.
So it'd be -5
Oh yeah, I see what you did.
on that side, and then 3 on that part, and then you draw it in the other two. So like,
So those numbers are your two asymptotes?
Right.
So where's two
look like that.
The two on top.
It's like the center of the hyperbola.
What is 2?
Just as.
So it's just that, or do you have to change
I
it?
don't know what that is because it's like dawning. I think so.
Same thing like this, but.
But hold off on your question about the two.
What is this, right?
I think so.
He's not telling us nothing.
Well, no, it's hard to tell because I don't know what your axes are. Where did you draw your two asymptotes?
3 and
What is 3?
-5. Okay, 3 with the y. 3 is the y and -5 is
Yeah, I mean, yes. It's x equals 3, right? It's a vertical line.
Yeah.
Yeah, x equals 3, and y equals -5. Yes.
I don't know what you said was.
I did it
I
wrong.
said in my head, but the way you said it. Okay.
Well, you're saying because it's up and down, it's a y,
Oh, okay.
right?
Okay.
Like a y. Remember the y-axis equation is x equals 0. That's what the y-axis is. It's confusing. I totally get that. Those should be your new, it's like your new axes. These are your new asymptotes. And so we're going to draw it in over here in this first quadrant-y looking thing, which includes some of the actual fourth quadrant. And then we're going to draw it down here. Now what does the 2 do? Yeah, it actually makes it taller. Because it's like we're multiplying by 2. But, I'm not even asking you to find points for these things, right? I want you to sort of get the general shape right. So, if you're getting the general shape right, and you make it a little bit skinnier, oh, that's going to look more like Scott's. But it's not, because Scott draws his so close to the asymptote. Yeah. But they're not really like that close to an asymptote. It's more like this.
Yeah, I spaced it out 1.
Oh, that's too far. I forgot how. height was starting.
So if we wanted to be lazy, could we have just put like a dot in the center of the axis that's already drawn on the graph and just label it as 3, -5?
Yeah,
So
and then use the line that's already there for you.
2,
Yeah, but let's, I mean, for now, we're going to say you have to draw the asymptotes.
2, wait.
Yeah.
So 2 means that it's further from.
Well, 2 means everything's multiplied by 2. Okay. So everything is a little bit, so this thing is, this point here is farther up than it used to be. This point here is farther up than it used to be.
Okay. And if it were can't be negative.
What would happen if it were negative?
It wouldn't be in. Well, I mean, it would go
It
like
crossed
past
the point.
it crossed into the.
Yeah, I mean, it would be in the second and fourth quadrants. If it were -2, or x minus 3 minus 5.
That's scary.
The center still hasn't changed,
No.
right? It's still 3 to the right
Two down.
and 5 down, okay? But that -2
That's why. It's
We make it undefined.
makes it where?
In the
I just said it.
That way.
Two.
And
Yeah.
then second.
It makes it in this,
but if you can't have it in the fourth quadrant,
or the second, wouldn't it
You
just
just
be
can't have them
undefined?
in 2. You can't have them.
You
like
can if
first
this-
or second.
oh, it's negative.
it'd be like saying you can't have an upside down parabola. Well, sure you can if it's negative out front. Okay, same thing.
I get it.
Because what we're doing is we're taking this thing and we're flipping it up here. We're taking this thing and we're flipping it down
So you
there.
can't have like
You just can't have.
you can't
first
have
or
something in the first or fourth at the same time,
Yeah, because then it wouldn't be a function.
or in the second and the first.
Oh,
Right.
oh,
It's got to pass the vertical line.
So it has to be diagonal from each other.
Yeah.
Okay.
Okay? Now, those are the only 3 functions
That we need to.
that I'm going to be asking you to know for now. Lines, which hopefully we know. Parabolas, which hopefully you're more familiar with now, with identifying the center or the vertex, and then drawing in a few points. And the multiplicative inverse function. That's this one. It's actually a crazy hyperbola that's been rotated 45 degrees. If you tilt your head this way, it looks like a hyperbola. And there's even asymptotes like a hyperbola has. Okay. Come back in 5 minutes, and we are going to do a little algebra first to get here, and then we'll graph it. All right? Algebra.
What's algebra?
Algebra.
Oh, it's even more.